In this video, we will be graphing and analyzing this rational function. Let's start with those x-intercepts. Remember from our notes, we can find the x-intercepts by setting the numerator equal to 0 and solving. So if I set this numerator equal to 0, that means I will have x squared equal to 0. If I take the square root of both sides, that's going to give me x equals 0. Normally I'd have to do plus or minus, but plus and minus 0 are the same thing. So that's just 0. So that means my x-intercept, which is always going to be something comma 0, this x equals 0. So that means the x-intercept is 0 comma 0. And I could go ahead and graph this point right now by going blow. Okay, there's my x-intercept. Now, how about that y-intercept? I can get the y-intercept by hand very easily. To get the y-intercept, all you need to do is let the x value be 0. Basically, plug in 0 for x. Now, I can either do that by hand or I can do it on my calculator. But if I let x equal 0, that means I'm going to have a 0 here and I'm going to have a 0 here. So that means, I have 0 over negative 16. 0 divided by anything is 0. So I know that the y-intercept will also be 0 comma 0. Okay, I could have gotten the same thing if I had put this in my calculator. So let's see, what do I have here? X squared over x squared minus 16. Alright, I'm going to need that anyway. I'll be using ask mode. Okay, let me clear out some stuff. Whoa! Didn't mean to do that. If you want the y-intercept, let x equal 0. So I can do that in ask mode by just substituting 0 in. And sure enough, I get 0 for y as well, just like I thought. So either way you look at it, you're going to get 0 comma 0 for the y-intercept. I've already plotted it, so there you go. Now let's talk vertical asymptotes. You get the vertical asymptotes by setting the denominator equal to 0 and solving. So if I set this denominator equal to 0, so I'm setting x squared minus 16 equal to 0. I would factor this, and that would be x plus 4, x minus 4. And I would set each of these equal to 0. So that's going to give me x equals negative 4 and x equals positive 4. So these are my vertical asymptotes. So x equals negative 4, x equals positive 4. Don't just put 4, put x equals 4. Don't just put negative 4, put x equals negative 4. So those are the vertical asymptotes. So I'm going to graph them as dotted lines. Alright, so I've got my vertical asymptotes going on. Now let's talk horizontal asymptotes. For the horizontal asymptotes, we have to think about these three conditions. It's all about degree. If the degree of the numerator is less than the denominator, it's y equals 0. If the degrees are equal, the horizontal asymptote is y equals a over c, where these are leading coefficients. If the degree of the numerator is greater, there is no horizontal asymptote. So what's happening here? X squared and x squared. The degree is 2 for the numerator and denominator. Since the degrees are equal, the horizontal asymptote will come from doing leading coefficient over leading coefficient. So that's going to be y equals 1 in this case. So I'm going to have a horizontal asymptote here at 1. Okay, so there's our horizontal asymptote. Now, we could do the domain right now without drawing the graph, because you could do the domain really just based on the vertical asymptotes. So the domain is going to be from negative infinity to -4, from -4 to +4, and from +4 to infinity. You really just have to look at these vertical asymptotes. So the domain is going to be from negative infinity to -4, and then -4 to +4, and then 4 to infinity, running out of space. For the range, you really have to graph it. You can't just go by the horizontal asymptote. You have to graph it to do the range. So let's graph it. Now the vertical asymptotes will tell me what values I need to use. So for example, one of my vertical asymptotes is -4. This is going to lead me to 4 x values that I need to use, because I need to go to the immediate left and right of -4. I'm talking decimals. I'm talking 0.5 units to the left and right. If I go 0.5 less than -4, that would be -4.5. If I went 0.5 to the right, that would be -3.5. If I went a little bit further to the left, that would be -5. If I went a little bit further to the right, that would be -3. So I need these 4 values on my chart for sure. Alright, so here I've copied these 4 values onto my chart. Now I have another vertical asymptote at +4. In a similar way, I'm going to get 4 values from this. So if I go 0.5 units to the left and right, like you do, I'm going to have 3.5 on the left and 4.5 on the right. If I went further to the left and right, I would have 3 and 5. So I'm going to need these values, these x values on my chart. Notice I didn't quite have enough squares, so I had to bootleg it up and add another square on the end. No big deal. You do the same. Now I just need the y values to go with this. Now I'm going to show you a couple of them, but the bottom line is I'm just using the table feature of my calculator. Don't forget that we are, so here's the function typed in, of course. I'm letting my calculator be in Ask X mode as I do this. Okay, so my first values here are -5, -4.5, and -3.5. So -5, -4.5, and -3.5. Alright, so I get these y values. These ugly fractions are not very helpful to me for graphing, so I'm going to convert each one to a decimal by highlighting it and hitting this toggle button right here. So this is approximately 2.8. I'm going to round this up because it's bigger than 5. So 2.8. Alright, I'll move down and do the same thing. This is 4.8. Again, round up because this is a 6. Okay, next is the -3.5. Toggle that. That is -3.3. Alright, I'm going to repeat that process until I have the y values for the rest of these other 5 x values. But I'm going to pause the video and just do that by myself. Alright, so I've come up with all of these 8 points. Now I'm just going to take these 8 points and I will plot them on my graph, and it will give me a good idea what the function is going to look like. Okay, here I have graphed my 8 points on the graph. And don't forget, this point right here in the center, that was the x and y intercept that I had from the very beginning. But that is a point on the graph, so it is useful. So looking at these 2 points over in the upper left-hand corner, I know my graph has to pass through those 2 points, and yet on the left side approach the horizontal asymptote, and then approach the vertical asymptote. So I really know that it's going to look something very much like this. Alright, similarly on the upper right hand corner, it's going to be identical, well, symmetric. Okay, so these are mirror images of each other. And then you see the upside down U shape that's happening here. So I'm going to go through these points, but I'm going to approach the vertical asymptotes on the left and the right. So it's going to be something like this and something like this. Alright, so this is what this graph should look like. Now I can do the range, but be very careful. If you look closely, there is a gap here. This upside down U does not reach all the way to the horizontal asymptote. So when I do the range, I'm not going to say negative infinity to 1 and then 1 to infinity, okay, because this portion of the graph only goes from negative infinity to 0. It stops here at 0. Alright, so there's the first portion of my graph. Now, sometimes I will use a bar like, don't like it when it does that. Sometimes I'll use a bar like this one to help me demonstrate how the range goes. Alright, because this bar will help me show that when I'm looking at this graph and I'm asking myself how low does it go and how high does it go. This lower portion of the graph goes from negative infinity to 0, and we have that written down already so far. And then there's a gap. There's nothing right in this area right here until you get to 1. And then it goes from 1 to infinity. So that's what's happening. I just realized I made one small mistake on this range. And so be very careful, because if I can make a mistake, if when I'm going too quickly, you could easily make a mistake too. Now it is negative infinity to 0. Don't need to erase that. The problem is I put parentheses here when I should have a square bracket. That's because looking at this portion of the graph that goes from negative infinity to 0, the asymptote is not here at 0. 0, 0 is on the graph. The graph touches 0. So 0 is to be included. Compare that to 1. The graph picks up here and goes from 1 to infinity, but 1 is an asymptote. And it never reaches the asymptote. So 1 is not to be included in the range. So 1 gets round, parentheses, but the 0 gets a square bracket because it's touched. It's part of the function. It's got to be included. Okay, let's talk about increasing and decreasing intervals. From left to right, as I go across the page, first the graph is increasing. Okay, now be careful though. When I talk about how the graph is increasing, the intervals, all I care about are the x values. So yes, this is increasing, but it goes from here to here. If I look just at the x-axis, this portion of the graph goes from here to here, left to right. Now when I say this left part, I'm really saying negative infinity because it goes forever. So my first increasing interval is going to be from negative infinity to negative 4. Okay, now then the graph jumps down here, and from here until the middle it's increasing. Now notice it's going uphill and then downhill. So it changes here at 0, 0. So looking at the x-axis again, Oh man, I didn't mean to do that. Okay, looking at the x-axis again, this portion of the graph goes from -4 to 0. Don't say negative infinity, because I'm only talking about the x value. So if you put your eyes on the x-axis, yes, this portion of the graph goes from here to here, from here to here. But x value wise, it goes from here to here, if you just look at the x-axis. So this portion of the graph goes from -4 to 0. So that's going to be another increasing interval from -4 to 0. Okay? And then it's decreasing until you get to the next vertical asymptote. Let's see if I can erase this without erasing my entire graph. Okay, so this portion of the graph that's decreasing, if I stare at the x-axis, it goes from here to here. So that's from 0 to 4, decreasing. And then when it gets to the other side of 4, it jumps up here. And now it's going to the right, it's decreasing again. So it's decreasing from 4 to infinity if I stare at the x-axis. From 4 to infinity, it's decreasing. Okay, 4 to infinity. Okay, and symmetry. The choices are even, odd, or neither. It's even if the y-axis splits this perfectly down the middle with mirror images on the left and right. So this is, in fact, even. It's identical on the left side and the right side of the y-axis. It would be odd if it looked the same if you turned it upside down, but it would not. So this is even symmetry. Alright, that is it for this problem. I hope this video was helpful.